So this is the second part of 6.1. We'll call it 6.1b. And our focus today is zero and negative exponents and using the properties that come along with them. So up at the top, there's a few properties for you to copy down. So first one is when we're using zero exponents, and the second one is when we're using negative exponents. So take a second, you can pause the video to copy these down, and then we'll talk about exactly what they mean. So for when we're using zero exponents, it says for any non-zero number a raised to the 0 power is 1. And then 0 raised to the 0 power is undefined. So basically for any number other than 1, or even any number other than 0, or even any variable, if it's being raised to the 0 power, it's equal to 1. So like 4 to the 0 power is equal to 1. Negative 2 to the 0 power is equal to 1. X to the 0 power is equal to 1. And then this one's a little tricky. If I have, say, negative 6 to the 0 power. So in this case, just the 6 is being raised to the 0 power, not the negative. So negative 6 to the 0 power, that negative would stay out in front, and then the 6 to the 0 power would become 1 also. So those are just a few examples of the zero exponents. And then for negative exponents. So for any integer n, and integers are just kind of the numbers that you think of like when you count, or even negative, including negative numbers though. So it could be like 1, 2, 3, or it could be -1, -2, -3, and so on, but it's no decimals or fractions. So for any integer n and any non-zero number a raised to the negative n is the reciprocal of a to the n. And if that doesn't mean a whole lot to you right now, that's okay. So let's say I have x raised to the -2 power. In order to have a final simplified answer, you want to make sure that you have positive exponents. You can't have negative exponents in your final answer. So to make this negative exponent positive, I have to take the reciprocal of the base. So if my base is x, I can think of that as x over 1. And then to find the reciprocal of it, I would flip it. So instead of x to the -2 over 1, it would become 1 over x to the +2 power, or 1 over x squared. So when you take the reciprocal, the exponent goes from negative to positive. Similarly, if we start in the denominator, so say I have 1 over a to the -3rd power. Sometimes we can kind of view these as like flipping over the fraction bar, for lack of better terms. So if I want to change this a to the -3rd into an a to the +3rd, I'm going to take the reciprocal, or I'm just going to flip this a up into the numerator. So it becomes a to the 3rd over 1. And then we know that a to the 3rd over 1 is just a to the 3rd. So we'll definitely do more examples of those. Negative exponents can be tricky, so don't be afraid to ask questions. So for example 1, evaluate each expression. So 6.7 to the 0 power. Well, anything besides 0 to the 0 power is just 1. So 6.7 to the 0 power is also going to be 1. And that's it. That's your final answer, just 1. And then for b, 2 raised to the -4th power. So I have to, because I have a negative exponent, I have to take the reciprocal of the base. So my base is 2. I can always think of a whole number as being over 1. So if I wanted to find the reciprocal of 2, I would flip that over, and it would become 1 over 2, and then instead of -4, it becomes +4. So when we flip it, it changes the sign of the exponent. So if you flip it from numerator to denominator, or denominator to numerator, it changes the exponent from positive to negative. So altogether I have 1 over 2 to the 4th, or we can multiply out 2 to the 4th, multiply 2 times 2 times 2 times 2, and we end up with 1 over 16. And then for the next example, just simplify an expression. It says simplify the expression 4x to the 0 over y to the negative third. Write your answer only using positive exponents. So we can do this in a few different steps. I know that anything raised to the 0 power is 1. So first I can simplify that x to the 0 power. So in the numerator, if this x to the 0 power becomes 1, then the numerator becomes 4 times 1, or just 4. And then the denominator, we didn't do anything to simplify that yet, so it's still y to the negative third power. So in the numerator, I'm going to go ahead and just multiply the 4 times 1 to get 4. And in the next step, we'll focus on changing that negative third power to a positive third power. So the property says that we have to take the reciprocal of the base, but a lot of the times what that looks like in like an actual problem is wherever your base with the negative exponent starts out, it's going to flip from numerator to denominator or denominator to numerator. So if it starts on top, it'll move to the bottom. If it starts on bottom, it'll move to the top to become positive. So in order to get this y to the negative third power to become a positive 3, I want it to move up to the numerator. So in the numerator, that 4 will stay there. That y to the negative third is going to move up there and become y to the positive third. And because that y to the negative third moved up, there's nothing left in the denominator other than just a 1. And if you want to write it, you can, but you don't have to write it. So definitely when we write our final answer, we don't want to include the 1. We just want it to look as simple as possible. So anything over 1 is itself. So altogether, this would just be 4y cubed. And then these are a few examples to practice on your own, so you can pause the video here and then play it when you're ready. So for the next problem A, negative 9 in parentheses to the 0 power. So in this case, the negative is being included with the 9. So that whole negative 9 base being raised to the 0 power is just going to be 1. So any base raised to the 0 power becomes 1. It would be a little bit different if it didn't have parentheses, if it was just negative 9 to the 0 power, because in this case, 9 is the base, not negative 9, because the 9 doesn't have the parentheses with the negative. So this one would be negative 1. The 9 to the 0 would become the 1, and the negative would have to stay out in front. But for negative 9 in parentheses to the 0, that's just 1. And then for B, 3 raised to the negative third power. So if we want to think of it in terms of a reciprocal, I can think of 3 as 3 over 1, and then to find the reciprocal, I flip that. So this becomes, instead of 3, it becomes 1/3 over, and this negative 3 turns into a positive 3. And then I can multiply out that 3 to the third power, so this becomes 1 over 3 times 3 times 3, so 27. And if we kind of talk about, or look at this through the viewpoint of what we talked about before, if I think of this as 3 to the negative third over 1, think about it. If I wanted to make that negative exponent positive, I would just flip it. So it started in the numerator. To make it positive, I'll move it to the denominator. And then for c, so I have negative 5 to the 0 over 2 to the negative 2 power. So try not to simplify too much at once, just because it can get kind of confusing that way. So I'm going to just focus on the negative 5 to the 0 power. So kind of like what we talked about with a, this negative sign is not included with that base of 5. This is actually just 5 being raised to the 0 power, not including that negative. So negative 5 to the 0 power without any parentheses is going to be negative 1, because the 5 to the 0 power becomes 1, and that negative just stays out in front. And then raised to the 2, over 2 raised to the negative 2. And then next we have a negative exponent that we need to simplify. So my negative exponent started in the denominator. So to make it positive, I'm going to move it up to the numerator, so up on top. So my numerator, that negative 1 stays up there. And then the 2 to the negative 2 power moves on top, but it becomes 2 to the positive 2, or 2 squared. And then now there's nothing left in the denominator, so it's over 1. But we don't have to include that in our final answer. So now I can simplify it fully. I can actually square the 2. So negative 1 times 2 squared, and 2 squared is 4, over 1. But anything over 1 is just itself, so you really don't need to include that over 1 part anymore, or at least for your final answer. And then next we can just multiply negative 1 times 4, so negative 4. So for the next one, simplify the expression 3 raised to the negative 2 times x raised to the negative 5th over y to the 0. Write your answer using only positive exponents. So we can do this in however many different steps we need to. You don't feel like you need to do it all in one step. I think the first thing I'm going to do is simplify the 0 exponent, though, because I know anything raised to the 0 power becomes 1. So I'm going to leave the numerator alone for right now, so it's still 3 to the negative 2 times x to the negative 5th, and then over y to the 0, which we know y to the 0 is just 1, or anything to the 0 is 1. And then now I have 2 negative exponents that I need to make sure that I get rid of. And for my final answer, I need my final answer to only have positive exponents. So if I have negative exponents, I need to flip them to make them positive. So if they start in the numerator, they're going to go down to the denominator. So I know that my 3 to the negative 2 is going to move down and become 3 to the positive 2, or 3 squared. And it just, whenever we move things, they just get multiplied by what is already there. So if we had a 1 here, it'll just be multiplied by 1, but anything multiplied by its 1 is just itself. And then now my x to the negative 5th, that's going to move down to the denominator as well to become x to the positive 5th. And everything down in the denominator will just be multiplied together. And now here's what's tricky. I moved everything away or out of the numerator, but it's not 0 there, because if it's 0 there, then the whole thing is 0, and that doesn't really make sense. So if you move all of your factors out, or all your powers out of the numerator, you want to leave a 1 there. So if all the different factors move out of the numerator or denominator, you can leave a 1 there. So I have a 1 in the numerator. Sorry, I think I said denominator before, but you can leave a 1 in the numerator or denominator. And then next we can just start to kind of multiply these together. So 1 times anything is itself, so I don't really need to include that. I can square the 3, so 3 squared becomes 9, and then times x to the 5th power. So altogether we have 1 over 9 x to the 5th power.